ancient technologies that were way ahead of their time. Let's get right into it. Number 9. Hero's Temple Doors, the illusion of divine power. Imagine standing outside a grand temple in ancient Alexandria. The sun blazes down, and a priest steps forward to light a fire on an altar. Suddenly, enormous stone doors swing open by themselves, revealing the sacred interior. No one touches them. No visible ropes, gears, or guards. To an ancient worshipper, it might have felt like divine intervention. But behind this mystical display was the brilliant mind of Hero of Alexandria. This ancient inventor wasn't just a tinkerer. He was an early engineer, working centuries ahead of his time. Using basic principles of air pressure and fluid dynamics, Hero created an early form of automation. Here's the science behind the spectacle. As the fire heats the air beneath the altar, it expands and displaces water into a container, increasing its weight. This heavier container pulls a series of ropes and pulleys that cause the temple doors to swing open. When the fire dies and the air cools, the process reverses and the doors shut. Hero's temple doors weren't just theatrical. They demonstrated a deep understanding of physics. This was not a magician's trick, it was an early form of pneumatics. In a way, Hero was laying the groundwork for automation and robotics, masked as religious awe. It's fascinating that what we call modern automation had its roots in religious theatre. The key lesson here is that necessity doesn't always drive innovation. Sometimes belief and spectacle are enough to push the boundaries of engineering. Had Hero's ideas been applied to civic life instead of temples, the Industrial Revolution might have started 1,500 years earlier. Number 8. Roman surgical tools. Ancient precision in medicine. When you think of ancient medical practices, you might picture leeches and crude tools. But archaeological finds, especially in places like Pompeii, reveal a different story. Roman surgeons used instruments that would not look out of place in a modern operating room. Scalpels with interchangeable silver blades, forceps capable of grasping tiny tissues, and even bone drills have been uncovered. Their craftsmanship shows an astonishing level of medical knowledge for their time. Silver, unknowingly to them, had antibacterial properties. While they didn't understand germ theory, they discovered through trial and error that silver blades helped reduce infections. It's easy to believe progress moves in a straight line, but Roman medicine challenges that assumption. Their tools show us that ancient societies often had practical knowledge rivaling our own. They just didn't have the scientific framework to explain it. It's a humbling reminder that progress isn't only about technology, but about the context in which it's applied. Number 7. Maya Blue. Chemistry without chemists. Maya Blue is a pigment so durable that it still holds its vibrant colour after more than 1,000 years. Found on pottery, murals, and even the bodies of human sacrifices, this pigment resisted the elements through hurricanes, humidity, and time. The Maya achieved this by heating a mixture of indigo dye and a special clay called palygorskite to a very specific temperature. This process created a nanocomposite, a term we only began using in modern material science. This wasn't just artistic brilliance, it was chemical mastery disguised as ritual. Without labs or microscopes, the Maya stumbled upon molecular stability. Their ability to engineer at such a small scale without modern tools suggests that experimentation, cultural continuity, and perhaps even spiritual importance all played roles in advancing technology. Number 6. The Nebra Sky Disk. A Bronze Age observatory. Discovered in Germany in the late 1990s, the Nebra Sky Disk turned out to be a 3,600-year-old astronomical artifact. This bronze disk is inlaid with gold symbols representing the sun, moon, and star clusters. 2 arcs on its sides mark where the sun rises and sets during the solstices. But this wasn't merely decorative. It served as a celestial calendar that helped its users track the seasons, plant crops, and possibly predict eclipses. It even shows the Pleiades cluster, used in many cultures to mark the start of agricultural seasons. What's astonishing is the level of precision involved. Bronze Age communities, with no written math and limited tools, created a device with astronomical accuracy. It challenges the narrative that ancient societies lacked scientific thinking. Instead, it suggests their understanding of the heavens was empirical, detailed, and practical. Number 5. Hero's steam engine. Wasted potential of the ancient world. Hero of Alexandria didn't stop at temple doors. He also designed a steam-powered device known as the Aeolipile. It consisted of a hollow sphere mounted on an axis with bent tubes that expelled steam, causing the sphere to spin. This was the first known steam engine in history, a working example of jet propulsion. Yet rather than use it to power tools or transportation, it was treated as a novelty or temple attraction. The Aeolipile is a sobering example of missed opportunity. The concept of converting heat into mechanical energy was discovered, but the societal structure didn't demand it. When labour was cheap and slaves were plentiful, innovation had no incentive. It reminds us that technology alone doesn't change the world. Context does. Number 4. The Nimrud lens. A glimpse into the stars. In ancient Assyria, a 3,000-year-old rock crystal was discovered, now called the Nimrud lens. It offers about 3x magnification and could have been used for fine craftsmanship or even basic astronomy. Intriguingly, Assyrian texts mention Saturn having a triple form and being surrounded by serpents, a poetic description eerily similar to Saturn's rings when viewed through a lens. Even if accidental, the lens opens questions about what ancient people saw. Were they able to observe planets and star formations with tools we thought they lacked? And if so, what else did they know that has been lost to time? This find pushes the boundaries of what we assume about ancient observational science. Number 3. The ancient Indian rust-proof iron pillar. Metallurgy ahead of its time. In Delhi stands an iron pillar over 1,600 years old that refuses to rust. Unlike modern iron, which corrodes easily, this pillar remains pristine despite centuries of exposure to monsoons and pollution. The secret? The iron has a high phosphorus content, forming a protective compound called misohyte. This layer is only a fraction of a millimetre thick, but provides powerful protection against oxidation. The most remarkable part is that this was likely an accident. Ancient Indian smiths didn't know the chemistry, but their empirical methods created something modern metallurgy still admires. It's another case where observation, tradition, and necessity produced results we can still learn from today. Number 2. Polynesian stick charts. Navigating by wave memory. While Europeans feared sailing beyond the horizon, Polynesian navigators mastered the Pacific using stick charts. These maps, made of palm ribs and shells, recorded wave patterns, currents, and island positions. But navigators didn't carry them. They memorized them and navigated by feel, lying down in their canoes to sense the ocean's pulse. This wasn't just navigation, it was body memory, turned into cognitive maps. Every ripple, reflection, and current became part of a deep-seated intuitive system. Polynesians showed that technology doesn't have to be external. Sometimes it's internalized through culture and discipline. Number 1. The Roman odometer. Pebbles and precision. To manage an empire, the Romans needed to measure distance. Their solution? A chariot rigged with gears that dropped a pebble every fixed number of wheel rotations. At journey's end, counting the pebbles revealed how far they had travelled. This mechanical odometer enabled the Romans to standardize road measurements, build infrastructure, and coordinate trade and military logistics. This pebble-powered tool seems almost laughably simple, but that simplicity made it reliable. No software crashes, no electricity, just physics and clever engineering. It reminds us that the backbone of any great empire isn't flashy, it's functional. So yeah, sometimes the dumbest solution is the smartest one. That's all for today. I'll be making similar videos in the future. Subscribe to see them.